All right, so this is 30-2, lesson 3, rational expressions and equations, simplifying rational expressions. So we've already seen the factoring them and then looking at common pieces. What we want to do is to turn them into simplest form is to cancel anything that is the same in both places. So if I were to look at this thing, I can factor this a little bit. This is 12x squared. And all I'm going to do is I'm going to separate both pieces. So I'm going to do my number part and my variable part. The number part is 12 over 2, which is just 6 over 1. The variable part is x squared over x, which is just x. So this just becomes 6x over 1, or I could just write 6x. If I have this thing, oh, and I need to include my non-permissibles. X cannot equal 0. In this case, it's a cannot equal -7 and -1. And then what I can do is I can actually look at what cancels. I have an a plus 1 here and an a plus 1 here. They cancel, which turns to 1. It's like one thing divided by another. Same thing divided by another is 1. So what I have left is a minus 6 and a plus 7. Now, the restrictions, the non-permissibles, stay with the equation even after they've been canceled. It's the math version of what happens in Vegas stays in Vegas. So once we've created this thing, it still has two non-permissibles, even though we can only see the -7 one here. The -1 non-permissibility stays with it. Now this thing here, I'll do this the right way first. I'm going to take out a 2 from the top and the bottom. And this just turns to 4y times 2. I can now kill my 2 and my 2 because that's common. I cannot kill my 4y and my 4y because they're not factors. This is a term, this is a term, and this is a factor. So I can't divide a term by a factor. I can't cancel it. What people are always tempted to do is go 8y over 8y. Boo boo! It would be great, except that it's not mathematically true. So don't do it. Don't be that guy or girl. When you see things like this one that have a -1 out front, what I'm going to do is I'm going to first always make this thing positive. So I'm going to make this x plus 7 over negative x squared minus 49. I could have seen this as a difference of squares here too, but I'm likely to have trouble seeing the overall. This is now going to be x plus 7 over negative x minus 7, x plus 7. And now my x plus 7 factor can cancel with my x plus 7 factor, leaving 1 over negative x minus 7, which is -1 over x minus 7, or 1 over 7 minus x. Either of those things is true. I would argue it's better to do this because you are less likely to get mixed up in other places. Up here, I can take out a 4p, leaving 3p minus 2. Down here, I can take out a 2p squared, leaving 3p minus 2. Now I can cancel a couple things here. First, the 4 over 2 makes just 2 over 1. P over p squared, this one can cancel with one of those p's, leaving still 1p in the denominator. And then the 3p minus 2 and the 3p minus 2 cancels out. Now, before I cancel those things, and look at me, I got behind, I need to write down my non-permissibles. Always non-permissibles before you cancel anything. So my non-permissibles here are x cannot equal 7 and -7. My non-permissibles here is p cannot equal 0 or 3p minus 2 means it's going to be, now if you're ever stuck and you're like, I don't know what the 0 and the limitation is on that, you could just write this, 3p minus 2 cannot equal 0, and then isolate for p. So I'm going to add 2 to both sides. 3p cannot equal 2. P cannot equal 2/3. So there's my non-permissible there. So positive 2 over 3. Just erase that out of the way just so I can see my next question. All right, here's what I'm going to do. On this one, I'm going to pull out the 3. This is going to be 3 times t squared minus 25 all over t plus 3 t minus 5. And then you're like, wait a sec, can I cancel those 3's? No, you can't. They have to be the same factor. This thing, though, can still factor. There's my difference of squares again. Yay, difference of squares. T plus 3 and t minus 5. T minus 5 and t minus 5 cancel. Look at me. I'm still going without doing my non-permissibles. Here we go. T cannot equal negative 3 and positive 5. Now I'm good. Now I can cancel. And so my final answer is there we are. That's the one. Now, sometimes we'll see using a common factor of negative 1. Again, my strategy is always make the variable part at the beginning. So if I look at this, instead of c or c minus 4, instead of 4 minus c, I'm going to take out the negative 1 from there. And now that's c minus 4. And this is going to cancel and cancel. Again, once I've made my restriction. So this thing's just going to be negative 1. The equation is, or the expression has a value of negative 1 for every value except for c equals 4. This one here, 2p squared, that's going to leave me with a p minus 4p squared divided by 2p, just 2. That gets me to there. Now down here, I'm going to take out a negative 8. By taking out the negative 8, that allows me to make this positive p and negative 2 for the 16. And now I can see that shared feature. Now again, I'm going to write down my non-permissibles before I cancel. My single non-permissible is that p cannot equal 2. This thing, 8, is just always 8, no matter what p is. So it has no more non-permissibles, only the one place where it can go wrong. Now that I've written that down, now I can cancel, 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 and over the 2 and the 8, I can make that just 1 over 4. So negative p squared divided by 4. There we are. Oh, and with the p can't equal 2. Yeah, that restriction stays. What happens in rationals stays in rationals. So area of a plot can be expressed as x plus 6 squared. The length is x squared minus 36. So what I can now do is I can go, okay, this is x plus 6 squared, which is my area, divided by my length. Now, I can instantly see this should probably factor. So x plus 6 squared over x minus 6x plus 6. And now I'm ready to go. I can start canceling things, I guess, once I write down my non-permissibles. X cannot equal 6 or negative 6. And then I can cancel out this one with one of these. This is really x plus 6 times x plus 6. So I cancel out one of them. So it's x plus 6 over x minus 6. And x cannot equal 6 or negative 6. Now, if the length of the plot is 28, well, I know that this thing is the width of the plot was the length. The length is x squared minus 36. So I can go x squared minus 36 equals 28. Now I'm going to add 36 to both sides. So x squared equals 36 plus 28. 36 plus 28. Why can't I do that in my head? 36 plus 26 would be 36 plus 36 would be 72. 22, 64. Ha! Look at me go. It's almost like I know what I'm doing. And now if I square root that, I get 8 and negative 8. But it has to be the positive value, so it's just going to be x equals 8. A plot is to be treated with fertilizer at a cost of 240 per square meter. Calculate the cost of the treatment. Well, if x is 8, then I can go back to the area. We go, okay, my area is x plus 6 all squared. If x is 8, 8 plus 6 is 14. 14 squared is 196 meters squared times 240 per meter. And that one I'm just going to type into my calculator. Again, a little mental math never hurts, but sometimes I just want to make sure that I'm all set. So 196 times 2.4, put a decimal in there. All right, so it's going to cost me about $500, $470.40. All right, that's that one done. If you need any help, come get help.